In this video, we are going to talk about how to create 1D and 2D arrays using dynamic memory allocation. Firstly, we are going to talk about 1D arrays. To create 1D array using dynamic memory allocation, firstly you have to specify of which data type the elements of this array are going to be. For example, I'm going to create an array of data type integer. For that, I would need an integer pointer. And using the new operator, I'm going to assign 4 elements to this pointer. Now what is actually happening over here is that the pointer points towards addresses, and this pointer is pointing towards the address of the starting index of this array. If I execute this code, you can see over here is that using this for loop and this integer val, I have assigned to this array numbers from 1 to 4 by incrementing in this integer val. How to use this dynamically allocated array? You can use this array like any regular array in C++ by using the keyword ptr and using the scare braces. You can specify the index at which you have the desired element that you want to print out. For example, right now I want to print out the element at index 2, which is 1 0 1 2. That element is 3. If I run this code, you can see that it is going to print out the number 3 over here. There's a concept of dereferencing which I'm going to explain to you. Dereferencing basically means that I am going to print out the value of an element of this array using by dereferring the particular address. How I'm going to do this is that the pointer ptr is pointing towards the address of the starting index of this array. Now if I add 2 into it, it is going to increment in that address the address of the starting element, the number 2, which will take it to 1 to this element over here. Now if I print this out, it is going to print out the address of this element over here that is present at index 2. If I run this code, you can see it has printed out the address of this value over here, which is present at index 2. Now what is dereferencing? By using static and round braces, I can derefer this address, and now I can print out the number 3. This is called pointer dereferencing. Now we are going to talk about 2D arrays. Now for creating 2D arrays, I am going to use a 2D pointer. I'm going to create a 2D array of data type integer, and I'm going to use a 2D pointer which is represented by double stack. Using the new operator, I'm going to create an array of pointers. In static represent 1D pointer, ptr 4. Now what I have actually done over here is that I have created an array of 4 pointers, 4 1D pointers, and I have used a 2D pointer to point towards the address of the starting index pointer. By incrementing into it, I can access all of the pointers, 1D pointers in this array. And for each 1D pointer, now I'm going to allocate memory to them. How I'm going to do this? Let me show you. ptr I. Now using the new operator, I'm going to assign 5 elements. I'm going to assign 5 elements to each 1D pointer in this array. Let me execute this code first. Is it giving an error? So as you can see, it has created a 2D array, otherwise known as a matrix, using dynamic memory allocation. For storing, I have used an integer val in which I have incremented and I have stored elements up to number 20 in this array. You can see this for double for loops over here. We can use this dynamically allocated matrix like any regular 2D arrays in C++. For that, I am going to show you how you can use it. But before that, let me jump into the concept what actually goes behind the working of this 2D array. For that, you can see over here is that when we create a 1D array, we use a single pointer of data type int steric, and using the new operator, we can assign 4 elements to this array. Now what actually happened over here is that the pointer points towards addresses, and this pointer PTR points towards the address of the starting index of this array. By incrementing in that PTR, I can go to the address of the next elements, and by dereferencing it, I can print out its value. What happens in the 2D array is that I am using a 2D pointer, and using the new operator, I have created an array of pointers. Now this is the important part. Using the 2D pointer, I have created an array of 1D pointers. So the 2D array, I have created an array of 1D pointers. This 2D pointer is pointing towards the address of the starting index pointer of that array, and by incrementing in PTR, I can go to the next 1D pointer and to the next 1D pointer. So what is happening in this piece of code is that I have used an in double stack pointer to point towards an array of 1D pointers. This one. And what is happening in this for loop is that I am assigning, basically I am assigning 4 elements to each 1D pointer. To each 1D pointer, I am assigning 1, 2, 3, 4 elements. And to next 10 pointer, I am assigning 1D pointer, I am assigning 1, 2, 3, 4 elements, and to next I am assigning 1, 2, 3, 4 elements. So in this way, we can create a matrix using dynamic memory allocation. To further explain the concept of dereferencing, I can show you an example. For example, if I have to don't mix that example I have shown you earlier, this one, with this example, because in this example I have 1 2 3 4 rows and 1 2 3 4 5 columns, whereas in the other example there are 1 2 3 4 5 rows and 4 columns. So if I talk about this example, I have to access the element 9 over here. How I can access the element 9 is that I can use the keyword PTR. The PTR keyword is basically the 2D point name of the 2D pointer. Now using these overloaded scare braces, this operator, I can access the element 9. I have to specify the row number in this, which is 1, 0, and 1, and the index, the element index, which is 0, 1, 2, and 3. So hopefully it is going to print out number 9. If I run this code, as you can see, it has printed out the element 9. Now let me tell you about the concept of dereferencing. This is gonna give you an idea that how actually the pointers are being operated. As I have mentioned earlier, the pointer PTR points towards address. The pointer PTR is a double pointer which points towards the starting index of an array of 1D pointers. Okay. So if I add 1 into it, it is gonna go to the next pointer which is pointing towards the second row. If I show you this slide, firstly, ptr was pointing towards the 1D pointer, this uh, uh, address of the array of pointers, and then when I added 1 into it, now it is pointing towards the second pointer in the array, which is at index 1. Okay, so if I derefer it, it is gonna give the address of that pointer. And if now I add I add a number 0, 1, 2, 3, 4, is it 0, 1, 2, and 3? It is present at index 3. If I add 3 into it, now what it is actually doing is that it has went previously to the second row, and now it is pointing towards the number 9. The element is present in column 0, 1, 2, the third index of this 1D pointer. If I do not derefer it, it is going to give the address, and if I do the static part, it is going to give the value 9. If I run this code, you can see dereferencing, it has printed number 9. This concept can be a little tricky, but this syntax and this syntax are approximately similar. If you have to understand this concept, you can write it down one by one, and you can see the addresses that are being printed. You can compare it, and you can visualize the actual concept, the actual working of the pointer that happen in C++ program.